In my last video, I compared the Sankey diagram in SAS Visual Analytics and Power BI. I'll put a link to the last video. And in this video, I showcased the use of analyzing a pathway in different settings. So I gave an example of people traveling at an airport from different locations to different locations, with the locations here being Amsterdam, Curacao, etc. I'll put a link to the video in there. Another important thing that I noticed when going deeper in the Sankey diagram is that it also, as any tool, has its limitations, specifically the Sankey diagram in SAS Visual Analytics. So as you can see here, I'm working with a data set that is based on gynecology care. I'm not sure how to pronounce that, gynaecology, OBGYN. So doctors taking care of female parts and childbirth. So in this case here, you can see the type of data that I often work with. And we'll see here the patient ID, which is obviously a fake patient ID in this case, the date on which a service was delivered, the code that is being used for a particular service, the name of the service, the names are in Dutch here. You can see the names of the different services. There are about 105 different services that they can provide. I'll just scroll down real quick so you can get an idea of all the different services that are being provided by the OBGYN. The amount of services that have been paid, which is usually one per service per day. The amount that was paid, in this case, this is the currency. And what I also did here is that I made my own categories where I convert the name of the services to a broader category, because I have here about 105 services and I translate these to a handful of services, so about 8 to 10 groups of services, so it becomes easier to analyze. What we see when I put that information in SAS Visual Analytics is that I get these Sankey diagrams that are very long. So you'll see here that the information is very long because there are a lot of different events that people go through. And the program, I think, might not be able to deal with the big amounts of data very well, and especially when I have a lot of different events. You'll see here that it also gives a notification where it says an artificial sequence order was generated for 300 paths that contain simultaneous events. And I can also modify the amount of paths that I select here. I can select based the amount of paths or the length of the path. So I have here maximum length put on 10, but let's say if I put it now on 30, and I update that, I'll change the maximum path to 30. I'll change this one here to 200. Then we will get these very long charts. As you can see, it now has 30 different events that it goes to a maximum of 30 events. And you'll see it gets really long. And to me, this kind of defeats the purpose again of a chart, of a visualization, because you want a visualization to be short, sweet, and comprehensive for your end users. And if I'm writing, for example, a memo to my colleagues or for my boss, then I'd like to keep my visualizations to simple visualizations that are to the point. And obviously, if I'm going to make a Sankey diagram of a maximum path length of 30, it really defeats the purpose because it gets really long. I might as well just give them 500 rows of data to look at, which obviously they're not going to do. So you see here, this is not, maybe not be the appropriate tool for these types of big data analysis, especially if I'm dealing with large volume of data where you often have people doing multiple services on the same day. So what you get with this type of information here, I'm just going to pick a random ID. You often see that they get the same that they get multiple things on the same date. Um, so I guess the Sankey diagram in SAS Visual Analytics doesn't really capture that well. So I went out to look for some other tools, and I stumbled upon the concept of process mining. So it's process mining, and it seems to be heavily dominated by particularly one person from Eindhoven, which is the city in the Netherlands, Will van der Aalst. And from what I can gather from the internet is that almost all process mining activities or packages refer to his work at some point, or refer to him as the pioneer of this type of work. So I went deeper in that. I watched a bunch of lectures on process mining. It looks very interesting, and it seems very relevant to the problem that I'm trying to solve. Because what I'm trying to find out is I'm trying to look for patterns in the patient journey throughout the healthcare sector. So I would like to see what does a patient journey looks like. And I've been trying to use a Sankey diagram for that. But as you can see, this Sankey diagram here with that is a length of 30. And mind you, it even cuts out a lot of data that doesn't qualify according to this criteria. So it's not even portraying all the data. It's just giving me certain criteria that matches, certain data that matches my criteria. And this might not be the best tool for the scenario that I want to figure out. So I've been spending some time on Coursera, and been following so this person, Will van der Aalst, his process mining course. And he recommends a particular software that was made by two of his PhD students, or developed by two of his PhD students, called Disco. So what I'm going to do now is I'm going to show this software that I'm very happy with. I just got a sample of this software. So it is called Disco. Let me see if I can find where to find this website. You'll find their software on this site here. I'll just type it in. You'll find it on this software here. So fluxicon.com/disco/. And you can find the software there. You can see again here this Mr. van der Aalst. And according to his course on Coursera, this software is developed by students of his to facilitate. They also provide open source versions of software that can do with it, but for my technical skill, it seemed a bit intimidating. So the free open source versions seemed a bit intimidating to me, and very time intense to learn. I also saw this video here from this person, Sebastian van Zelst, about process mining in Python that I've been looking into in a Python package that is called PM4Py, process mining 4Py. But again, it just looked like it is possible, but it just didn't look very appealing to me, all the steps that I need to take to get there. So I contacted this company here, Disco, and they offered me a sample license so I could check out their software. And I've been opening it here, so I'll show you guys. And mind you, I've only been working with it now for maybe 50 minutes to an hour. I've been experimenting with the software, and I am flabbergasted by how useful it is and how to the point it is to what I'm trying to analyze. So again, I'm showing you, this is the data that I want to analyze, and I'm particularly not really interested in these individual items, because these services, they're too broad in their possibilities. As you can see, the data is in Dutch because the data I work with is typically in Dutch, but I've translated a few of them here. I've translated the group categories here to English names, so it becomes easier for you to understand. So you can see here there are consultations. So when an OBGYN sees a female patient, the cesarean section, and 3 different types of diagnostic, type A, type B, type C. The forceps delivery, where the OBGYN does a delivery to get the help get the baby out through the vagina rather than the C-section. And the hospitalization, and premature delivery, and finally surgical procedures done by the OBGYN. So these are all different services that they provide, that I've grouped according to about 105 different codes that they send invoices to an insurance company, and I've grouped them into about 10 groups. So I'll show you now how easy and how useful this program here is, Disco, that I'm really enjoying now. So, and this is really how fast it goes. So I just go here, I open a file, I select the file that I just created, and in this mode now I have to specify which column will be used for what. So I need to label them, and my patient ID column, that is my case column. The date here, that will be my timestamp, so that gives a sequence of events. And this service category here, that will be my activity column. So that is the event or the activity. It's very important. So this is my activity. This one here I will just take because I will just call it other. And the number paid, I call it resources. But the most important one is the case. So which is this one. This is the case, is the most important one. The sequence order is really important. So it knows in what to order information by. Unfortunately, I don't have timestamps in my data. I only have dates. So that's unfortunate. You would also like to know by the minute which procedure comes earlier, but I can only tell by dates. That's simply how the data I work with is structured. And here you have the different categories. Okay, the different events. So I click here on Start Import. And now it will read my data, and it immediately produces a very interesting graph. So I'll just zoom in on it. And you'll see this graph produces information that is very insightful. It's just a relatively short and simple graph that gives me a lot of information. And as you can see, the default here is measuring the frequency, but I can change the frequency also to the case frequency, because in my case, I'm more interested in the flow of the amount of patients and not necessarily in the amount of the frequency of each patient. So patients can do the same service multiple times, but I'm more interested in knowing how they flow through services than the exact amount. So I changed it now to the case, and the cases are the individual, the distinct count of the patients. So as you can see here, we can visually inspect the data, and we can see how the flow goes of this particular pathway. So I'll just zoom in a little bit. We can see here that here's this where upon consultation, a lot of patients go to diagnostic type B. You can see here the diagnostic type B. And we can also check the absolute frequency, which is the amount they went there, but also the case frequency, which is the amount of the distinct count of the individual patient. So this is the count, and this is distinct count. And we can also see that after diagnostic type B, a certain portion of people gets a C-section. And we can also see that after diagnostic type B, a certain portion gets the forceps delivery, upon which they again revert back to consultation. So they get a consultation after they give birth with the OBGYN again. Here you can see also a small group that after diagnostic type C, so they get type B and then type C, they go to premature delivery. So we can already maybe conclude that diagnostic type C in a way is maybe somewhat of a predictor for premature delivery. Again, the numbers, it's a wide your 4,000, this is 10. But I'm just mentioning, might be something interesting to look at. Here you can see that diagnostic type A loops back to consultation. So we know now that people come in for consultations, they take diagnostic type A, and they do not move on directly to, let's say, a C-section or a surgical procedure. No, they get another consultation first. So this is a very interesting insight to know that. And then after they get another consultation, they either go to diagnostic type B, after which they get either a C-section or a forceps delivery. And or, for example, they go to the surgical procedure, which is not necessarily related to childbirth. So these are the other activities that a OBGYN does that has to do with female reproductive organs that are not necessarily related to childbirth. So I've distinguished them here in childbirth related ones, and here not childbirth related ones. And you can see that they really follow different paths, right? So you can see the hospitalization is related to the surgical procedure. And after the surgical procedure, many of them, again, get a consultation by the OBGYN. So this insight for me here is really very fascinating to look at. And, and actually, I would say even more useful than the Sankey diagram that I showed in this previous video, because this information is just not intelligible anymore. You see how much information that is I mean, it doesn't, it's not useful anymore. It's just too much information. I've, I've, I've gotten useful insight from the Sankey diagram and SAS Visual Analytics, but it's not useful for the type of analysis that I'm busy with at this moment. This year is much, much more useful for what I'm working in. So I also noticed that I can check out the statistics on a more case-by-case basis, and I check out the different types of variance this process creates. And let me see, I saw here individual cases. Here you can see I can click on individual cases and see how they run. So this is a case with just one event, which is a consultation. But this is a case with 17 events. And I can really follow here the amount of days between one event. So consultation and diagnostic type B, there was 1 day of difference between those two. And then on the same day, they did other things. This is all the same day. Then there's 16 days later, this patient gets this here. And as you can see, we can really monitor this patient's pathway. Here, 23 days between diagnostic type C and consultation. Here, 77 days. And that's how it moves on. So I can check that this is in a case with a patient with only 5 instances. And this is very interesting. And here I can check the different variants. So apparently this program, Disco, creates different types of variants based on what it sees. So you can see a large part of the variance only has consultations, which is logic. They go for a consultation and then do not continue the care path, or they go to a doula or a midwife to continue their care path, right? So not all females that need to give birth will do that with an OBGYN. They might just go for a single checkup. Here you see variant 2, where you can see variant 2 only consists out of type B and type C diagnostics and the consultation. And as you can see, it just shows all these different variants and the percentage of them. Again, I'm not exactly sure how to interpret all of this. I haven't played with it that much, but this is definitely useful for what I'm looking at. More in particular, I am busy for current research. I am busy to compare the patient journey between 2 different competing groups of OBGYNs. And I've been trying to find techniques that I can compare their behavior with. So I would like to see if their patient pathway differs for a lot of them. And for this purpose, I've been looking into this tool. So let me see if I can filter this, because this is, let's see, filter. think I could filter it by the OBGYN type. And I'm just going to try this out. So I'm just going to remove one type and see how that works. Let's see, apply filter. So yes, this is the other type of OBGYN. And you see already the amount of consultations has dropped from about 9,000 to 2,500, which is what I was expecting, because this group has less patients, and I can visually inspect again if their behavior is different. So if the patient travels through a different path with this particular group of healthcare providers compared to the other group of healthcare providers. You can even see here the percentages. This is 29% of cases, 19% of events. So if I were to report on that, in my case, maybe it's too simple, but I will just make a print screenshot out of it. And here, so I'll just make a print screenshot out of this particular group here, let's say group 1. And then I'm going to filter again and try out with the different groups. So I'm just going to remove this one and activate this one and apply this filter. And here we have it. We see that there is a different structure. I'm just going to zoom in. So we see a different type of behavior again with this particular group. Let's see. I'm just going to paste it here. And this is group N. And I'd also like to maybe compare this with this details with the average, right? But here I can already see the differences between the groups and in their procedures. I haven't analyzed it yet, but this would be definitely something I would like to look into as a data scientist to try to see the discrepancies and also maybe find explanations for these discrepancies. So that was my finding for today. I'm very happy with the software. You can find it here on this website. I'll put the link to the website in the video so you can check it out for yourself and you can find it right there. There it is, this website here. So thank you for your attention, and I'll see you next time. Thanks.